I will put my stopwatch then. Good afternoon, everyone. Thank you for having me. Thanks for the invitation. It's much appreciated. So my name is Nikitas Xenakis, and I'll be taking you through how to build a highly available and scalable logistics platform using Oracle 19c and GoldenGate 19c. And hopefully I will explain how to do that, whether you are running on-premises platform or you're in the Oracle Cloud. Just a little bit about the agenda. I think that should, that's normally a 45 to 50-minute talk. I'll try and whiz through this in half an hour. So there may be a couple of areas that I will take you through in a bit more detail. Others which I will skim through in the interest of time. Just a little bit about me. I've been doing this for around more than 20 years. And I am a CAB member for Oracle Database, Oracle RAC, and GoldenGate, and I am part of the Global Leaders Database Development. My social media handle is Twitter, LinkedIn, for you to connect. Feel free to do so. I'll be interested to hear your thoughts and views, and please reach out. So, just a little bit about the Coop. The Coop is a leading convenience retailer in the UK. It's been there since the 1800s. You can see how our stores used to look like. I think in Switzerland you've got something equivalent, your Coop society. So very, very similar convenience retailing. But what does the Coop look like in 2021, and why do we need all that investment in high availability and scalability? Well, we've got an annual revenue of 11.1 billion. We've got a mixed model of our own stores, but we also have running wholesaling, franchising, e-commerce, and home delivery. As you can imagine, with COVID, that's skyrocketed. We've got big distribution center, which we run ourselves, 14 of those into the 15th in early next year. So, and we are servicing other Coop societies. So that's in total in excess of 10,000 outlets that our logistics network supports. So you can imagine the scale and the requirements. In terms of our business demands, well, we're entering new channels, as I've explained: wholesaling, franchising, e-commerce. COVID-19 has shifted a lot of demand into home delivery, which makes things, even more demanding from a HA and a scaling perspective. And we tend to use where we can reinvest our in terms of fuel for growth, try to eliminate technical debt and reinvest that into the business. Some cool technologies that our platform underpins is this autonomous robot. So basically, you place an order at the store through the app. We pick at the store, we deliver the order to your doorstep with this autonomous robot. Using the app, you can unlock the robot and you can have the delivery at your doorstep. In terms of our context, our technology and business context, we have 2 data centers. In terms of the on-premises footprint, we've got presence in all major clouds: AWS, Azure, and Oracle Cloud. And we have quite a huge, as I said, network that we need to support. So all these initiatives, franchising, e-commerce, home delivery, and our own convenience retailer. Well, the one thing all these initiatives rely on is a highly available and scalable logistics platform. And how do we do that? Again, just to give you an appreciation, we cover pretty much all postcodes in the UK. So we've got a store in every postcode. We push around 1 billion transactions a week. From a logistics, if you are on logistics background, we're running 11.5 to 13.5 million cases a week. And the strict requirement is that 98% of those picking transactions must complete in less than a second. otherwise productivity suffers. Also, we've got around 500,000 real-time operational reporting, which is vital for the depot operation, for the effective depot operation, which also needs to complete in less than a second. And I'll explain how we achieve both of those. But why invest in high availability? Why should you do that? And to a greater extent, maximum availability architecture. Well, you have to be able to cover or cater for system failure, hardware failure, human error, developers running wrong code, or even DBAs, protect DBAs from themselves, harming the system, running perhaps a wrong installation code, or even a much bigger failure in terms of data center outage. Now, what we quantified, so we sat with a business and we quantified that for each depot, if we have 20 minutes of downtime for that depot, that quantifies to a 5-figure loss. And that is loss of productivity. So that's basically pickers. If you can imagine, we have people picking either through voice or RF guns. So this is based on payroll. So you got people basically sitting there doing nothing. Now, the cost of 20 minutes of downtime per 7 depots, and I'll explain why 7, because we consolidate our database layer on 7 depots. If we were to lose, either one data center or our rack cluster, which has got 7 depots, that is quantified in 6 figures. And again, that's not just on reputational damage or loss of revenue from sales, i.e. empty shelves, but this is just pure on payroll. So that's a very, very strict, very clean assessment from a finance perspective. So you can imagine why the investment to high availability is important. Anything more than 20 minutes per 7 depots is in the 7 figures, and anything more than an hour is pretty much incalculable. So we cannot calculate because there's so much that relies on that logistics network to be highly available, and everything is kind of linked to the supply chain. In terms of the investment to scalability, well, we want to be able to open more distribution centers on the same platform. So we want to be able to scale without or with minimum changes. We want to be able to push more load on existing depots according to demand. And I think COVID-19 has pushed that to the limit for us. So you can imagine since March 2020, we've been running every week almost at Christmas Eve peak trading. So you can imagine that the scaling and the stability, the importance for stability, availability, and scalability. We want to be able to capitalize, but also want to operate and in our new markets for franchising and home delivery. And how do we achieve that? Well, lucky for us, or lucky for all of us, including yourselves, Oracle has done quite a lot of work in that, where they've tested quite a significant set of blueprints. And those blueprints, when they come together under the banner or under the umbrella of maximum availability architecture. Typically, it covers not only database layer, or should I say database platforms, but also Fusion middleware, because middleware is quite important and you have to address that. It covers deployments either on-prem, using either commodity hardware, engineering systems, or Oracle Cloud. So your architecture can be applied in any of those, depending on what type of platform you prefer. It is focused around HA, DR, and in terms of Oracle Cloud, you can run things in OCI with either virtual or bare metal. Our preference in terms of the next steps is to run Oracle RAC on bare metal with or XACS, which is Exadata Cloud Service. These currently have been the most attractive for us in terms of both meeting the non-functional requirements, but also in terms of performance. There are several tiers in terms of platinum, gold, silver, bronze. The one I'll be taking you through is the platinum. Considerations for the platform, well, RPO, how much data can you afford to lose? For us, that's zero. RTO, how much downtime can you afford? Or how quickly should you be back up? Or should you ever be down? Well, that for us is zero. So it's zero data loss and zero downtime. Performance after the event, whether you lose a single component or whether you switch over to your disaster recovery side. Well, again, for us, there should be no degradation in an event of either a single component failure or the whole cluster, i.e. the whole data center failure, where we move to our disaster recovery side. And in terms of application outage, well, should you hide the application outage? Should that be transparent or not? Well, for us, in terms of single component failure, within the DC or within a single availability domain, that should be transparent. But in terms of failing over from completely onto a different data center, we have some considerations which are application specific, so that cannot be transparent. We have to do that in a controlled manner. So it is automatic and fully transparent for the DB layer, but not for the app layer. That requires a different approach. So our strategic architecture, in terms of our two data centers, which are 10 miles apart, is we run a OHS layer at the DMZ for external access. We run internal load balancers, i.e. NetScalers, facing an internal OHS layer, which are fronted by a 3-node WebLogic cluster and a 2-node rack database with DataGuard and GoldenGate. So that's our reference architecture on premises. In terms of our footprint in Oracle Cloud, we have a WAF layer, which is there in terms of protection, security protection, DDoS attacks, etc. We use mostly Oracle PaaS services, so load balancer as a service for a software level load balancer, and WebLogic marketplace for a 3-node WebLogic cluster, mapping what we have on-prem in terms of compute. That's less risky. And then DBCS, or I think it's called now PaaS, where we deploy a bare metal 2-node rack database with a standby into a different region. So in our case, what we're trialing at the moment is London and Wales, the two regions in the UK. But you have the options to do that in Frankfurt as well. The call out on this, and an important point, is make sure that the regions have got at least 3 availability domains for maximum resilience. So again, the MAA design patterns, which are for, strategic for co-op, are a 2-node rack with 1 to 3 PDBs. With 19c, you can have up to 3 PDBs. With a WebLogic middle tier running with data sources out, which run through GridLink, specific data sources, GridLink, which automate the HA. And where we need to share external files in the applications here, we use ACFS at the DB layer, presented into the app layer through HANFS as a NFS version 4 or later share. In case you have non-Oracle middleware, which many applications or third parties use that, you can still do that. So you can run your JBoss or your Tomcat, non-Oracle middleware. You can use the Oracle client, and you can configure your TNS in such a way where you can achieve transparent application continuity. Just check to see how I'm doing with time. Catch my breath. I beg your pardon. Yeah, 40 minutes. So moving on swiftly. The design patterns in OCI, very similar. We can we can run up to 3 PDBs in OCI. I think that's our preference. And in terms of middleware, again, we can use either the WebLogic Marketplace or a newly deployed service, which is WebLogic through the Oracle Kubernetes deployment. In terms of our challenge currently in the use case, as I said earlier on, 98% of the picking transactions have to complete in no more than a second, while at the same time we have to provide real-time operational reporting onto our depots. In terms of upgrades, also we have to achieve those with zero or near zero downtime. So we do that through GoldenGate currently. In terms of a high-level architecture, this is what our original architecture looked like based on Oracle 12c. And I should stress, if you're not on 19c, that's not a problem whatsoever. This architecture applies all the way from 12c release 1, 12c release 2, 18c, 19c, or even further. Now, as you can see, and let me just quickly take you through it, that's our primary hosting 6 to 7 depots with an active data guard standby. Then you've got a second primary, which is on the second data center with its active data guard standby back to the data center A. And if you can see, the two verticals represent our two data centers. And this one over here, hopefully you can see my cursor, represents the SCI, or should I say the supply chain intelligence and real-time operational reporting database, which again, has got its own active data guard standby. Now, a little bit detail on how this works currently, and as you can see, there are they're all 2-node clusters. Now, that's primary source 1, and that's primary source 2, and that's our GoldenGate target. So again, 14 distribution centers, or should I say 14 schemas from source 1, 7, and 7 are populated into this SCI target. So if you were to do this on 19c, as I explained earlier on, the architecture looks identical. So there's no concern if you're not jumping on 19c, which I would advise you, because you're going to get the biggest lifetime for that. Again, a little bit more detail on the architecture. It's an active deployment. So we are running live services out of both data centers, and also moving on to the OCI deployment into both regions. Each cluster will have a standby on an alternative region. The reason for doing that, whether you do that for the data centers, for a data center deployment or an OCI deployment, is so that if you completely lose a region or access to that region, or completely lose a data center or access to that data center, only half your logistics network is affected. From a GoldenGate perspective, because we are replicating all the transactional source onto the analytics target, we have individual pumps, replicas, extracts, pumps, and replicas for each schema to eliminate single points of failure. So we do that across each node. So we balance the schemas. So we have 4 schemas in node 1 and 3 schemas in node 2, or 3 and 3, depending on how many depots we run. That way we can scale both horizontally and vertically. So we can scale vertically with horizontally with Oracle RAC, or we can also scale vertically with GoldenGate, because we can have multiple extracts, pumps, and replicas. We use the active data guards snapshot standby to resolve data issues. So we had one of those issues, which hopefully the blog over there, if you go to that blog, you can get a bit more info, where basically we had a corrupted schema. Rather than doing any a full flashback on the back end and affect all the other schemas, we use the active data guard standby. So you use that snapshot standby flashback to just before the corruption, the logical corruption, extracted the schema and corrected the data at the source without affecting any other of the depots. As I explained earlier on, that architecture can be applied on commodity, Exadata, and OCI, either do DBCS on Oracle RAC on bare metal or XACS. You can even do that if you are into the cloud customer, you can also do that on XACC. I think I've explained most of that. We're running on-premises dedicated storage, and we're running also, we apply some quality of service to protect the voice traffic from our depots into the data centers. I won't take you through GoldenGate in terms of the detail of 19c, but I think I will assume that you have a high-level understanding. It is a log-based change data capture technology. It is meant to replicate through heterogeneous source and targets. It can be applied to Oracle and non-Oracle. Our use case is based on Oracle to Oracle replication on a sub-schema basis. So we are replicating a subset of our schema for each individual depot instance. Its classic architecture it looks like this. You've got an extract, pump, and replica. So the extract basically is a log miner process. It's almost like a log miner process which mines the logs, generates trail files, pump process, sends those to the collector process, which the replica picks them up and applies to the target. Why use it? Well, as I said, we use them for real-time operational reporting as well as the online upgrade. How did we decide to use it? Well, we decided based on a comparison between Active Data Guard. The reason why we went down that path is, one, we wanted replication granularity. Also, we wanted to run source and target on different versions. And for the investment that you do, you get a lot more with GoldenGate rather than with Active Data Guard. Plus, you have the bonus that you can actually, with a GoldenGate license, you can use Active Data Guard anyway. In terms of the scale, you can see, the amount of reporting that goes on per hour. So you got around 5,000 reports peaking around midday. So we have to service we have to service those at much less than a second. How do we implement it? Well, the original 12c, we used 2-node rack with fast sync for Data Guard and GoldenGate 12.2. That was based on Linux 6.5 on the DB layer and 7.1 with DBFS to protect the all-important trail files for GoldenGate. And we use OEM 13.2. In terms of 19c, we used Red Hat 7.5, 19.3. We are in the process of looking at the latest patch, the 19.10. The only thing you need to be aware for this is to go with a Grid Infrastructure Agent 9.1, which supports the link, almost like the glue that connects GoldenGate services with the DB. In terms of the GoldenGate operations, I will just skim them through, but you can see the all-important DBFS resources, GoldenGate service, and GoldenGate service, GoldenGate resource, and GoldenGate VIP. You need a GoldenGate VIP for each node. So again, that's source A, source B, target. Again, you've got a GoldenGate service, DBFS, GoldenGate VIP, and GoldenGate resource. In terms of how do you manage that cluster? Well, we stop GoldenGate using those scripts, which I will share later on. So stop GoldenGate resource service, then DBFS mounts, then VIP, then DB. When you start them based on a database service that will pull up all the dependent resources, so a lot less for you to do. That just shows the extracts, pumps, and replicas per node. I will just, again, skim them through in the interest of time. Monitoring your errors, the GGSER log is the all-important, the equivalent of the database alert log, but each of the extracts, pumps, and replicas, as you can see, will have its own report, which you can look and investigate for errors. The lag, the all-important view is GG-like history that can show you an output like this, which you can investigate your incoming lag. Microservice architecture is very similar to classic, only it's fully REST enabled. Again, in the interest of time, I won't take you through in detail how that fits. Hopefully for a separate session where I have a little bit more time. But again, it is fundamentally based on classic architecture. We've evaluated and we started using it because for me, it gives a really nice segregation of duty between GoldenGate administrators and database administrators. Plus, it kind of cloud enables your on-prem MAA architecture when you move onto your MAA journey into Oracle Cloud. Again, very similar tech stack based on 12.1 and very similar tech stack as I've taken you through earlier on with 19c. A couple of use cases we've applied, DB source 12.1, target 19.3, so that kind of simulates the online upgrade using GoldenGate. We've tested all the scenarios, source node failover, target node failover, source database full switchover to ADG standby. I should point out that we use the ADG standby when we need to do any planned maintenance operations at our GoldenGate target. That way, there is no outage or no stability issues to the real-time operational reporting capability that we provide for our analytics colleagues. We also use Multi-Tenant. We've tested that as of the 19c announcement. The part that I like is that, again, I can isolate resources and logical schema at the PDB level, and which makes my colleagues at audit and risk very happy because I can show them how I can protect individual sites rather than schema consolidation. We did go down the autonomous database route in terms of an application separate to this, which is servicing. It's an externally facing application. So that's basically for our franchise operation. We have a number of stores that place orders, and they come through our DC operations and our data centers. The reason for that is that all the ordering and downstream systems still sit on premises. In terms of why you should consider it, which I'm pretty sure that you already have, for me, it is the quickest path to Exadata. It is very simple to provision and set up. From a security, patching, compliance, and audit, it is a very, very simple and also meets all the requirements. You can combine it with your DevOps colleagues with some, because it is based on a very high degree of automation. And one of the features I like a lot in terms of the serverless is the auto scaling. Some of the challenges is that I think currently the ATP is only available in one availability domain, so you have to implement data guard. It does make it a little bit more involved, for production workloads. I think ATPD is more production fit for purpose. Some of the specifics that you need to look into is you have a limited amount of tools with ATP. SQL Loader is not available, so you have to rethink how you upload your backend code or how you run your interfaces. You can use data pump, you can use external tables, and you can use SQL Developer. But in terms of data integration, you have to rethink that. Our specifics is that if you have traditional PLSQL code that either uses UTL file for inbound or outbound, you have to replace all that with DBMS Cloud. That's the best recommended approach. Disaster recovery, I think I've already covered, so I will skim through that. For OEM, again, we use MAA Platinum with always on monitoring, which is a really cool Java app that gives you or lets you receive notifications even if you know, in the event of you're operating OMS, you need OMS downtime, or perhaps you need to patch OMS. In terms of lessons learned, the all-important document I will advise you for GoldenGate replication is that document ID, because not every schema is a good candidate for replication. That will run a nice validation for you. Our future plans is to use GoldenGate Hub on-prem, and at the same time we're trialing the new, just released last month, GoldenGate Cloud Service, where we can either do on-prem to on-prem replication or even OCI. Journey to MAA, well, our investment has paid off. You know, we've had several outages, planned and unplanned. We had 6 server failures within like 6 to 8 months. We didn't suffer a single blip. We've also, as I explained, with the use of snapshot standby, we were able to recover human error in terms of schema corruption, and we're also so there was 0 business impact basically on all these scenarios to our logistics mission critical operation. And I've been quite open and vocal about it in social media. This is not just I'm not just saying that for sales or which I'm I'm not part of Oracle. So in that case, it is out of our use cases. Just a bit of MAA content, and hopefully I think I'm just 1 minute over time. Thank you very much for listening. Hopefully you found that very interesting. I will gladly ask any questions that you have. Thank you.
Thank you very much for sharing your experiences on this quite interesting and complex architecture. So far, we do not have any question in the question and answer box. So basically, we are through. Once again, thanks. Hoping that we will be able to welcome you on-prem conferences and physical conferences again here in Switzerland.
Definitely.
Your slides will be also shared. This is managed by Clemens Blailey. So people who want to contact you directly, they can then. Okay.
Sure.
Thanks again.
Great. Thank you.
Thank you, and have
everyone.
Have a nice day. Have a nice evening.
Have a nice day. Thank you.
So for the people logged on this stream, we will start in about 11 minutes for the next session.